So now we need to put this into proper scientific notation. Remember, it needs to be between 1 and 10. So to make that happen, we would have to make it 1.31. So 1.31. Now, that's a small number, right? Which indicates that our exponent will be negative. How far did we move that decimal from where it was to where it is? We moved it one place. So it would just be times 10 to the negative first. That, to me, is the easiest way to do that problem. They wanted us to do it something like this. They wanted us to set up a division problem and use our properties to finish it. So looking at A, 2 times 10 to the third divided by 8 times 10 to the eighth. You could totally write those numbers in standard form, like regular numbers, divide them, turn your answer into scientific notation. Or your big boy numbers in front, like the 2 over 8, you can just divide those. Now 2 divided by 8 would be 0.25. And then these, the 10s, are the same base. So remember, when you have the same base, you subtract the exponents with division. So we're doing 3 minus 8. Now, again, scientific notation, it's fine to have negative exponents. You don't move them under a fraction or anything. So 3 minus 8 would be negative 5. And then make sure it's in proper scientific notation. 0.25 is not going to work. So we have to make that larger, make it 2.5. And remember, if you make one of those things larger, then the other thing has to go smaller. So I'm going to make my exponent smaller than negative 5, meaning negative 6. This is the same answer you would get if you wrote them out in standard form, divided it, and then adjusted into scientific notation. So trying this one, we're dividing the normal numbers. 7.5 divided by 2.5 is 3. And then on the 10, we're going to subtract the exponents. So we're doing 12 minus negative 4. Ooh, but Mr. Plant, if we subtract negatives, aren't we really adding positives? That's right, computer screen. So 12 plus 4 would be 16. Make sure it's in proper scientific notation. 3 falls between 1 and 10, so we're good. So 3 times 10 to the 16th power. Last one. We'll divide our numbers in front. 4.2 divided by 12.6. We get 0.3 repeating. So let's just leave it there. 0.333. We're going to subtract the exponents. 5 minus 2. And 5 minus 2 is 3, so 0.333 times 10 to the third. Is that in proper scientific notation? No! We need to make that 3.33. So we made that larger, so we need to make the exponent smaller. Smaller than 3 would just be 2. Cool. What do we got now? What do we have now? Awesome mixing, some matching. 5 to the 9th over 5 to the 2nd equals 5 to the blank. We know we subtract them. So what's 9 minus 2? 7. 2 to the 4th over 2 to the 3rd. If we subtract those exponents, we would get 1. 3 to the 2nd over 3 to the 5th. If we did 2 minus 5, we'd get negative 3. And that's what they want there. It's a fill-in-the-blank question. If I said simplify that, I would want you to drop that under a 1, make it 1 over 3 to the 3rd, and then simplify that. Last one, and then we'll start the next video. So if we simplify the top, 5 squared times 5 to the 3rd, that'd be 5 to the 5th. The denominator would also be 5 to the 5th. So if we subtract the exponents, 5 minus 5 is 0. We'll finish up the rest of these in the next video, hopefully.